In our next section, we're going to talk about the zone-based policy firewall's application inspection that allows us to look into the layer 7 payload of web sessions or instant messenger or voice over IP connections in order to match and change the individual parameters that are going inside the actual application. Now, some of the common matches that you would typically do with the application inspection would be things like to limit what are the particular HTTP commands that a user can issue. Like if I wanted to prevent someone from uploading files to the website with the HTTP post command, or to limit what are the specific URLs that a user can or cannot visit. For inspections for mail traffic, like for a send mail, we could say what are the maximum number of recipients that you could have in an individual message that would potentially cut down on spam if there's some sort of open mail relay in the network. But the key is that these individual applications are going to have different types of inspections, whereas the HTTP payload is obviously going to be different than the IMAP mail payload or a SIP voice call. Now, the syntax logic for this configuration is going to be fairly similar to the ASA's application inspection with the modular policy framework, where again we're going to match the traffic with a class map of type inspect. But the key is that these are going to be protocol-specific class maps or layer 7 class maps. Inside here, this is where we would match the application-specific fields like the HTTP commands or the URL or the particular mail commands. Once we have classified the individual application match we're trying to use, the next thing is that we're going to determine what do we actually want to do with the traffic. And that's going to be accomplished with the policy map type inspect. But again, here, this is going to be a layer 7 policy map that is specific to that individual protocol. So from the application policy map, we're going to be calling the application-specific class map and then performing our individual application-specific actions. So we'll see that a policy map of type inspect for HTTP would have different potential actions of a policy map type inspect for SMTP or for POP3. Now, once we know what is the type of traffic, how are we going to inspect it, we could also call the parameter map, where previously we saw the parameter map that was of type inspect that was used for changing the TCP normalization features, like what are the limits of the half-open sessions, are we doing the audit trail, what are the timeouts for the UDP sessions. In the case of the parameter maps for the application inspection, most of the time we would be calling regular expression parameters, because this is going to allow us to match any type of arbitrary string inside the application payload. So I could say look inside of the mail payload and filter out this specific keyword based on the regular expression string, or the same case for the HTTP URLs. Now, the issue with this, when we're actually doing this implementation, is that it assumes you have an application level understanding of what is actually going on in that protocol. So if you don't understand what are the actual fields that the HTTP server uses, what are the different methods that you can use for uploading or downloading files, and what is the specific syntax behind them, then it would be fairly difficult in order to build one of these policies. So for these type of applications, a lot of the times you would rely on the documentation to see what are the basic examples that they're doing for maybe URL filtering or for mail-specific inspections. Generally, you wouldn't need to be an expert on these type of topics because you're generally going to rely highly on the documentation examples to figure out exactly what we're going to do. Now, in our particular case here, what we're going to be looking at is router 4 configured as a web server, where router 3, again, is running the zone-based policy firewall, where the connection to router 4 is the inside portion of the network, and the connection to the frame of the network is the outside. So we have clients on the outside network, on the untrusted network, that are trying to send web requests into our server. This means that the actual inspection is going to happen in the outside to inside zone pairing. We saw the previous example of this when we were doing the TCP normalization, that router 3 has a class map that says match the traffic that's going to the web server based on an access list and based on the protocol. So we're saying match protocol HTTP in addition to match an access list. Then we are inspecting that inside of the policy map. Now, to apply an application level inspection, when we look at the current syntax on router 3, if we look at the show run section class map or policy map, we see we have the class map that is matching the server's traffic. It says match all HTTP server class is the name. It says it has to be the protocol HTTP, but it also has to be this particular access list. So this is where we're constraining it to the actual IP address that the server has assigned. This HTTP server's class is then called from the outside to inside policy that says to inspect the traffic with the particular parameters that we configured before, where these parameters are the TCP normalization, like what are the maximum incomplete sessions on a per minute basis, on a per host basis, overall, what are the TCP timeouts, what are the maximum number of sessions that we can inspect, etc. So technically those are not application level inspections, they're more just information about the layer 4 header that we're tracking the conversation that's going on at the TCP transport layer. But what we want to do next is to actually look inside the web payload to figure out when someone is actually sending a request to that server, what's inside the actual HTTP message. Now, in order to do that, inside this class type inspect HTTP service class, we're going to call a service policy. And the service policy is then going to be referencing the policy map type inspect that is for HTTP, where the policy map type inspect HTTP is going to call the class map type inspect HTTP, which then in turn matches the actual fields that we want in the actual application. So when you look at the final configuration, it can be kind of confusing how it's all tied together. But again, the key of using the zone-based policy firewall, or similar to the ASA's modular policy framework, is that the final resulting configuration is generally more modular than using something like the IP inspect command with the content-based access control. So let's take a look at this on the command line, where currently router 4 is configured as the web server. It has the HTTP server process enabled, and it's also configured as a DNS server. Right now it has two host entries. These are going to one of its own addresses, the 34.4 addresses. Now if we were to go to the web client, which is the Windows machine here, this device is pointing at router 4 as the DNS server. So if we look at the ipconfig/all, we can see it says the DNS server is router 4's address. Since the DNS is being inspected by the policy on router 3, if I were to ping www.abc.com, I see that the DNS resolution is successful, and the actual ICMP ping is working because that likewise is being inspected. Now, if I were to browse to this address and go to www.abc.com, I would see that this individual flow is being denied. And the reason why is that the address that it's resolving to, this 34.4, is not one of the addresses that router 3 is actually inspecting for. And we can see the alert message occurring. Router 3 says, I'm dropping the HTTP session on the particular zone pairing because in class default I have the drop action. Now if we look at the show access lists, the access list HTTP servers is matching the 172.16.4.4 address, but it's not matching the 34.4 address, which is what we are trying to resolve. So again, this configuration is very modular now, Because if I had an additional web server that I wanted to protect with the same parameters and the same application level inspection, the only thing that I would need to do now is go to IP access list extended, HTTP servers ACL, and say permit IP that is going to 172.16.34.4. Since the access list is being called from the class map called from the policy, it means then whatever parameters that I had applied to the class overall should now apply to the server that is resolving to this address. Okay, so we can see now there's no problems with browsing to www.abc.com. Likewise, if I were to do the other entry which I configured, www.xyz.com, this is telling us that the DNS resolution was correct and the inspection for the HTTP traffic was correct. So now let's say we want to limit the actual HTTP packets based on the payload. And in the payload, we're going to be matching on the URL string, where I want to allow the traffic that is going to this XYZ, but I want to deny the traffic that is going to abc.com. So again, configuration-wise for this, the next thing we would need to do is to figure out how do we actually match that traffic. So how can I categorize URLs that are going to abc.com separately from ones that are going to xyz.com? Where again, this is going to be specific to the individual application. So we're going to configure a new class map that is type inspect, but this time it's not a regular layer 3, layer 4 class. It is an application class that is just for HTTP. And I'll say that this is the HTTP application class. So again, I'm trying to make my naming of the policy as specific as possible. So it's essentially self-documenting when I look at the resulting configuration. So for this HTTP class, if we look at the match option, it says you can match either the request, the response, or both the request or the response at the same time. Where the request, this would be the client asking the server, am I allowed to use this particular method? Where HTTP GET, this would be your normal downloading of web pages. If I were to say HTTP POST, this would be for uploading files like through a web upload interface. So maybe there's some of these that you would want to disallow for your users to run. If we want the web server to be read-only, maybe I don't want to allow them to do POST. Or I don't want them to be able to make a directory or move any files or delete a file. So this would then assure if there was some problem with my actual web server application, whether this is Apache or IIS or some other server, maybe the server got compromised, but if I have this extra layer of protection in front of it, I'm still preventing someone from deleting my index.html or for uploading an additional file that's going to overwrite something else. But again, the key behind this is that you would have to know what do these methods actually do in order to figure out what's an appropriate application level inspection. Another one that we would typically want to match here would be the URI. Okay, the URI here, this is where we could match what is inside of the actual URL. Now we could call a regular expression here, which is then going to match what's the actual URL string that we want to. I could also say like what's the length of the request. So if I wanted to say if the URL string is over 512 bytes, maybe there's some sort of well-known threshold that if you go above, it's going to cause some sort of buffer overflow on the actual web server. So we could limit the traffic based on that. Now in this particular case, I'm going to actually look at the string, which would then need to be called by the regular expression. Now, depending on what particular direction you want this to occur in, it could either be, as I mentioned, the request, it could be the response, But the thing is that the requests are sometimes going to be different fields than the response. So again, you need to know at the actual application level, how does HTTP work? For most of these, if you were to match both of them at the same time, if I were to say to match the request and the response, then it's more likely that maybe the match is going to be only the request or only the response, but I can generally catch it either way if I do it with both of them. Where specifically I want to look in the header, and I want to look for a particular regular expression. So we could see, like we could say content type, where content type would be like for your MIME types. Maybe I don't want people to be able to use MP3 files or maybe Java files. But in this case, I'm going to call a regular expression that is just going to look for any ASCII string that is inside the actual web payload. Now we can see here the regular expression is then going to be called from a parameter map. So really it means before I actually configure this class map and match the regular expression, I need to define what are the parameters. So similar as to before where we did the HTTP normalization, the parameter map is now going to be type regex as opposed to type inspect. And this will give it a name. I'll say that this is going to be our denied URLs. So these are the ones that I want to limit that the client cannot get to. And now we're going to call the pattern. Now again, the issue with this is that you would need to know what's the exact regular expression syntax in order to match the particular string that you want. Now the regex patterns are going to be case sensitive. So we'll see that if we did a match that says something like abc.com, generally this is not going to be enough, because for one thing, if the user was going to www.abc.com, this is not the same string as just abc.com, or if they were going to a capital B lowercase c.com, likewise that's not going to match. So a lot of times you have to be very, very granular in the matches that the regular expressions are using. We saw this before on the ASAs. One thing you can do on the ASAs is to look at the show run all regex, and it'll give you an idea of how some of the syntax works. Like for this one here, it says for the MSN Messenger regex, it's looking for the case insensitive string application / x-msn-messenger, where inside of these brackets we're saying it's either uppercase A or lowercase a. Then this one here is saying it's either a / or a \, where the \ is the escape sequence for the regular expression. So two backslashes together is actually saying escape, then the literal character /. So it's saying / or \. Where in router 3's case, probably just saying the pattern is abc.com is not really going to be what we would want. It would need to be something a little bit more complex, where we could say, I want to look for, let's say, anything before abc.com, where dot is any character, asterisk is 0 or more instances. So dot star is going to be anything. Then there's going to be an actual dot. So I would need to escape this with a \, \dot, abc, escape the other dot, / or .com. So essentially what this should match is that you have anything that ends with .abc.com. But again, this is going to be case sensitive. So right now it's only matching the lowercase strings. So now I have the parameters. Next thing I'm going to do is go back to the class. The class says to match either the request or the response. So I don't care what direction it's going in. But in the header, if you see the regular expression that is the denied URLs, then the class's match is true. Now, I don't define what I'm actually going to do with the traffic here. That's going to be defined separately with the policy map. But here I'm just saying I now know what the traffic is. It's an HTTP packet that is matching this specific string in the payload. Next thing I would need to do is to actually define the policy map. Or I'll say the policy map is type inspect, but the difference now is that this is a specific HTTP inspection policy. So I'll say that this is the HTTP application policy, where the HTTP application policy is calling the class that is type inspect, that is the an HTTP class specifically, and it is the HTTP application class. Now, the idea behind this is that I could have separate classes inside of the policy, where maybe I'm doing one inspection for one server separately than an inspection to a different server, or maybe I'm logging the URLs that are going to abc.com, but I'm not logging the other ones. Again, the key is that it's just making the configuration more modular. So now I'm saying if you get to the point where it's web traffic going to the server and it has abc.com somewhere in the header, what do I actually want to do with it? Do I want to allow the packet? Do I want to generate a log message? Or do I additionally want to reset the connection, which is basically going to deny it? But I'll say both of these at the same time. I want to log the packets and I want to reset them. Now, the last step, if we look at the show run section class map or policy map, I now have my application level class, which is this one here, the application class, that says match the regular expression denied URLs. Then this is referenced from the application policy. It says if those URLs are matched, I'm going to log the traffic and reset it. But right now this is not actually applied anywhere. So now I need to take the HTTP application policy and call it from my outside to inside policy, where the regular inspection is occurring on the HTTP server traffic. So inside this class, HTTP server class, I now need to say, look at the service policy that is for HTTP, and it's the HTTP application policy. So this is where we're doing the deep packet inspection, or the DPI. Now, the URL filter here, this would be used if we're using an outside URL filtering service, like a WebSense server, for example. But in this case, we're just doing the actual application match locally with a regular expression. Okay, so now let's actually test this out. Let's go to the web client, and let's open up these new again. In either case, I should still be able to ping abc.com or ping xyz.com. So we can see this is not limiting the ICMP. It's also not limiting the actual DNS request. What should happen now is that I should still be able to get to xyz.com, which I can. But if our URL string match was correct, I should not be able to get to abc.com, which we can see we can't. Now, also notice that the page did not hang there while it was waiting for the connection. That's because router 3 is generating the reset. And we could see the log message did occur. It says in the header, this regex was matched. So we're resetting the connection. If we were to change this to say A.B.C, and sometimes this is going to depend on the actual web client. I'm not sure if this particular version of Internet Explorer would allow us to do this, but if we could send the case-sensitive string, then we would not be able to catch that with the policy. So you can see here when I enter case-sensitive abc.com, it's automatically normalizing it to lowercase, which means that router 3 is matching that. Now, if I were to go to some other sub-URL, let's say www.1.abc.com, let's try this again here. And what I would then need to do is on router 4, let's put a DNS entry for this, www.1.abc.com. And I'll ping www.1.abc.com. We can see the resolution is correct. If I now actually go to open it, likewise, this is denied because the way the regular expression is matched is I'm saying look for any string that is occurring before the .abc.com, which is what the .* is allowing us to do.